Hello guys, I'm Sagar from Sri Venkateshwar College of Engineering. Today I'm going to explain the probability distribution. Let's see what are all the contents. Introduction based on probability, example of probability, probability distribution, formula based on PDE, problem based on PDE, types of probability distribution, binomial distribution, Poisson's distribution, real-time example for PDE, random variable, types of random variable, and then conclusion. Now let us see the introduction. Probability. The probability of the events E is given by P of E is equal to M divided by N, where P of E is the probability of the event, M is the number of the favorable outcomes, N is the total number of events in the sample outcome. The probability of non-happening events is P of E dash is equal to 1 minus M by N. Hence, P of E dash is equal to 1 minus P of E. Theorem of probability, addition theorem of probability, multiplication. Now let us see one example for probability. Example of probability. When a card drawn from a pack of 52 cards, find the probability of getting A, king, B, king or a queen. Solution. Number of probability outcomes n is equal to 52. Number of favorable outcomes m is equal to 4. Probability of getting king is p is equal to m divided by n, that is equal to 4 divided by 52. The number of favorable outcomes m is equal to p of king plus p of queen is equal to 4 plus 4 is equal to 8. Therefore, p is equal to m divided by n, that is 8 divided by 52. It gives the answer as 2 by 13. For probability of getting a king is 4 divided by 52, because the 52 cards contains the 4 kings. Out of 4 kings in the 52 cards, the answer is 4 divided by 52. And for king or a queen, it means the king and also queen was to be included, that is 4 plus 4, it is equal to 8. 8 divided by 52 is the answer. Now let us see the probability distribution. Probability distribution is a random variable x, shows how the probabilities of the events are distributed over the different values of the random variable. When all values of a random variable are aligned on a graph, the values of its probabilities generates a shape. The probability distribution has several properties. For example, expected value and variance that can be measured. It should be kept in the mind that the probability of the favorable outcomes is also greater than 0 and the sum of all the probabilities of all the events is equal to 1. Now let us see some formulas on probability distribution. Mean. Mean is equal to summation of x into p of x. Variance. Variance is equal to summation of x into x minus mu whole square into p of x. Standard deviation rho is equal to square root of summation of x minus mu whole square into p of x. If for each value xi of discrete random variable x being assigned a real number p of xi such that p of xi is greater than or equal to 0, or summation of p of xi is equal to 1, then the function p of x is called as a probability distribution. Therefore, the set of values xi, p of xi is called as a discrete probability distribution of discrete random variable x. The function p of x is called the probability density function. Now let us see the types of probability distribution: normal distribution, uniform distribution, binomial distribution, Poisson distribution, exponential distribution. Poisson's distribution. A Poisson's distribution is a discrete probability distribution, meaning that it gives the probability of the discrete outcome. For Poisson's distribution, the discrete outcome is the number of items an event occurs, represented by k. You can use a Poisson's distribution to predict or explain the number of events occurring within a given interval of time or space. Events could be anything from the disease caused to customer purchase to materials tricks. The interval can be any specific amount of time or space, such as 10 days or 5 square inches. P of x is equal to m power x e power minus m divided by x factorial. Now let's see the real-time examples for the probability distribution. Probability distribution are used in many sectors. Here is some of the examples where the concept of probability distribution are used in the real time to describe the populations of the real life variables, test scores in a class or a standardized test, weight of adult individuals in a population, blood pressure in a population, internet download speed, birth weight of the newborn babies, finding the success and failures, batting average in the baseball, etc. Random variables. If a real variable x is associated with the outcomes of random experiment, then x is called as a random variable or stochastic or variatic. The random variable is a real valued function whose domain is the sample space of the random experiment. It is represented as x of sample space is equal to the real number. Random variables are usually denoted by x, y and z. It may be denoted that different random variable may be associated with sample space S. The set of all the real numbers of the random variable x is called as a range of x. Now let us see the examples for random variables. Suppose a coin is tossed twice. Some of the random variables can be defined as a x is equal to number of heads in outcomes, b y is equal to number of tails in the outcomes, c z is equal to number of two consecutive heads. Find the random experiment for all three cases given below. Now let us see the solution part. A outcome for x is equal to head head minus a2 comma head tail or tail head a1 tail tail a0. Hence random experiment id r of x is equal to 0 1 2. B outcome for y is equal to head head a0 head tail or head tail head a1 tail tail a2. Hence the random experiment id r of x is equal to 0 1 and 2. Outcome for x is equal to head head a1 head tail or tail head a0 tail tail a0. Hence the random experiment id r of x is equal to 0 and 1. Now let us see the conclusion. Probability distribution are a crucial elemental concept in the probability. You are now familiar with the name and shape of the common probability distribution. You have found that the structure and the type of any probability distribution vary according to the features of the random variable distribution like discrete or continuous. That's it for today's video. See you guys in the next video.